Today we're going to review linear relationships. This is a continuation from our Unit 3. So, I'm going to review linear relationships using an example shown here. This graph shows the cost of producing 1,000 copies of a school yearbook as it relates to the number of pages in the yearbook. This is my y-axis, and that represents my cost for the yearbook in dollars. My x-axis, which is my horizontal here, represents the number of pages. The line shown in dark blue represents the relationship of the cost of the yearbook as determined by the number of pages. I've also represented this graph in a table of values. In this table of values, when I have 0 number of pages, it will cost me $8,000 to produce the yearbook as determined on my table of values. At 50 pages, it would cost me $11,000, and so forth from each of these points as determined on this graph. Now, to determine if this graph and this relationship between the number of pages and the cost of producing the yearbook is linear or not, we have learned a method called first difference. Now, if you can recall, the first difference requires that we look at how the x changes, so how we move from one value to the next along my table, and how this changes with the change in my y value, which is my cost. Now, this relationship will be linear if my change in my y over my change in x is the same. So let's look at the change in x. To go from 0 to 50, I have to go up 50. 50 to 75 is plus 25. 75 to 100 is plus 25, and 100 to 150 is plus 50. Now, looking at my change in y, from 8,000 to 11,000 is plus 3,000. From 11,000 to 1250 is plus 1,500. To go from 12,500 to 14,000 is plus 1,500 again. And from 14,000 to 17,000 is plus 3,000. Now, neither my change in x or my change in y is the same, but that doesn't tell me if it's linear. It's looking at how the y changes with my x changes. So, if I take my delta y, which is 3,000, and I divide that by my change in x, which was 50, I will get 60 as my first difference for the first column, for the first row. If I look at my second row, I have 1,500 and divide that by 25, I will get a first difference of 60. And if I continue this, another 15,000 with another 25, I will still get 60. And last row, I have 3,000, and I'm going to divide that by 50. And my answer again is 60. So now that these are all the same, I know that this relationship is linear. Okay? So the first point I'm going to put under here is that for it to be a linear relationship, the first difference ratio between the two variables is constant. The second way, which I've also uncovered, is that I can just look at the graph, and if you can see that the two variables create a line on the graph, and therefore it is also a linear relation. So whether the first difference is constant, or if the graph is not a line, a straight line, then the relationship between the two variables is a linear relationship.